Okay, you have you're playing a fantasy role-playing game, and the outcomes are determined by rolling polyhedral dice. Some dice have 4 sides, some all the way up to 20. You roll a 16-sided die 5 times and observe the number on the top of the die. How many possible outcomes are there? Well, you're rolling it 5 times. So I'm going to put there, I got 5 slots to fill. And each time there's a possibility of 16 numbers coming up. So that would be 16 to the 5th power. $1,048,576. Now, part B says, how many outcomes in part A do the 5 rolls produce 5 different numbers? So now the numbers can't repeat. So again, I'm rolling it 5 times. So for the first roll, I'd have 16. The second roll, I'd have 15, 14, 13, 12. So that would be that's a permutation. And that would be 16, choose 5. Or I could just multiply those out. Okay, what's the probability that at least 2 of the rolls are the same? So we're going to use the complement rule here to find the probability that at least 2 are the same. That would be 1 minus the probability that none of them are the same, or all 5 are different. So to get the probability that all 5 are different, we take the number of outcomes, which was 1,048,000. That's our denominator. The number of ways that you can get 5 different numbers, that was the answer to part B. And then I go 1 minus that fraction. So I did that over here on the calculator, and it says go out to 4 places. So that would be 0.5001. Okay. Mr. Beckray often uses a computer program to randomly select 4 students from his class of 24 to solve a problem on the board. How many possible 4-student teams can be created from 24? So that's going to be 24, choose 4. Okay, and now this is going to be a combination. So I'm going to go 24, combination, 4. One day, Mr. Beckray poses a particularly challenging problem, and his random number generator produces a team of 4 students that includes 2 of the top 3 students in class. What is the probability that a randomly selected group of 4 students will include 2 of the top 3 students and 2 of the remaining 21 students? All right, so our denominator is how many different ways you can pick 4 groups of 4 out of 24, right? Then we want to know how many different ways can I choose 2 of the top 3 students. So there's 3 top students. How many different ways can I choose 2 of them? And then 2 of the remaining 21 students. So I got 21 students left, and I'm doing combinations of 2. If you recall, these 2 values have to add up to 24, and then the 2 how many you're picking have to add up to that value. And now we enter that into our calculator and get our probability. Okay, so our numerator would be, we're going to do 3, choose 2, and these are combinations. Okay, so that's 3. Okay, and then we got 21, choose 2. That's 210. And then 24, choose 4, we've already done. And it says round to 3 places. So the third number is a 5. You look at the 9, it tells you to round that 5 up to a 6. Okay, the probability that a randomly selected group of 4 students from the class will include at least 2 of the top 3 students is 0.061. Do you suspect that Mr. Becquerel rigged the random name generator? Okay, remember our threshold for this was 5%. So if this is bigger than 5, which it is, okay, this is 6.1%, then it's very likely that this just happened by chance. Okay, there's no funny business or shenanigans going on. So our threshold for it being unusual is 5%. So right now we don't have evidence because it's somewhat likely that the random selected group of 4 students will include 2 of the 3 top students by chance. Okay, so I do not suspect the teacher rigged the random number generator.